Today, Evroprom is recognized as a company with one of the largest stocks of used chillers in Europe, supported by its own in-house test facility. The secondary equipment market offers many options, but the key question remains the same. Will the chiller operate reliably on site? The only way to be certain is to test it under real operating conditions by cooling or heating a propylene glycol solution to the temperatures required by the client. That is why water testing is the foundation of our process and one of our key differentiators. Here is how we do it. After verifying the main parameters, replacing oil and filters, and checking the refrigerant level and quality, our technicians connect the chiller to the test station. The station is built around a 5-ton tank filled with a propylene glycol solution. The glycol is preheated using a heat pump to approximately 25 degrees Celsius. The system is equipped with hoses of various diameters and pumps with different capacities. This allows us to regulate flow and simulate real operating conditions, from small systems to full industrial load. The chiller is connected using hoses selected according to the required flow conditions. Once the system is filled, we check the operation of both the test station pumps and the chiller itself. We inspect for leaks and ensure there is no abnormal noise from impellers or bearings. Before startup, we perform an additional check of fan motor windings and bearings, ensuring smooth and quiet rotation. The technicians then connect pressure gauges, verify baseline parameters, and configure the controller according to the required temperature set point. Only then do we begin the test. Compressors are started sequentially. We monitor current draw, pressure differentials, and listen for any abnormal noise. For inverter-driven compressors, we also verify load control and speed regulation. Next, we fine-tune the refrigerant flow. We check the operation of the controller logic, including ERV functions, as well as the EVD, electronic expansion valve driver. During the test, we continuously monitor the entire refrigeration circuit, high and low pressure, superheat, subcooling, as well as refrigerant and oil levels. All sensors, pressure, temperature, and flow, are checked and calibrated. We set operating conditions from plus 20 degrees Celsius down to minus 12 degrees Celsius. For heat pump units, from plus 20 degrees Celsius up to plus 60 degrees Celsius. We also configure compressor staging based on the required set points. Throughout the test, technicians monitor all parameters via the controller, sensors, pressure gauges, and clamp meters. The test is performed under real load conditions, allowing us to fine-tune the chiller to stable and reliable operation. Only after we confirm that the chiller reaches the set point, maintains stable performance, and operates without errors, do we record the results. An engineer records the test on video and prepares a detailed test report with actual operating parameters. This report is provided to the client. We invite you to attend the test in person or join remotely and observe the process together with our engineer to see firsthand the reliability of our equipment and the professionalism of our team.